to learn rotary motion today. The definition of linear velocity is a point on a rotating object is the distance the point travels along its circular path per unit of time. The formula is v equals a over time, t. The angular velocity is the point on a rotating object is the number of degrees, radians, revolutions, and so on, through which the point turns per unit of time. The formula is omega equals theta over t. We got A, which is arc length, equals radius times theta. We divide both sides by t. We have A over t equals theta times radius over t. And A over t is linear velocity. Theta over t is angular velocity. So we have another formula. Linear velocity equals angular velocity times radius. The conclusion, linear velocity equals a over t. The angular velocity equals theta over t. The linear velocity equals radius times angular velocity. Ship's propeller problem. The propeller on a freighter has a radius about 4 feet. At full speed, the propeller turns at 150 revolutions per minute. Question A. What is the angular velocity of the propeller in radians per second at the tip of the blades at the center of the propeller? We have already had the angular velocity at the tip in the question, which is 150 revolutions per minute. So now we have to convert it into radian per second. 150 revolutions over 1 minute times 2 pi radian over 1 revolution times 1 minute over 60 seconds. The answer is 5 pi radian per second. At the center, it has the same angular velocity at the tip. So the angular velocity at the center is 5 pi radian per second. Question B. What is the linear velocity in feet per second at the tip of the blades at the center of the propeller? At tip, radius equals 4 feet. Linear velocity equals radius times angular velocity equals 4 times 5. So the answer is 20 feet per second. At center, radius equals 0 feet. Linear velocity equals radius times angular velocity. So the answer is 0 feet per second.